Hello again. In this video, we look at combinations. Suppose we put three balls with different colors in a bag, red, green, and blue. How many different ways can we select two of the balls out of the three? This is called a combination problem. In this case, we say what is the combination of three objects chosen two at a time, or simply 3 choose 2. And we have two ways of denoting that. Either we say C of 3 comma 2. C stands for combination. The bigger number, the total number of objects, comes first, 3 in this case. And the second number is how many we choose each time. And that is 2 in this case. Or we can order them as a column. 3, the total number at the top, and how many we choose at the bottom. So in either case, we say 3 choose 2. And in a combination problem, the order in which the objects are chosen does not matter. Okay, it doesn't matter whether the red ball is picked first or the blue ball, but we pick 2 out of 3 in this problem. And what is the question? What is the answer to this question? What would be the answer to this question? It's easier to think of how many ways you don't choose the remaining ball, right? If there are 3 balls and you choose 2, then there is one left out or left in the bag. And that one can either be red or green or blue, and there are 3 ways. So the answer is 3. And in general, in a combinatorics class, we learn this formula for the combination of n choose k. N is the total number of objects. K is how many you choose at a time. And that formula is n factorial divided by k factorial times the difference, n minus k factorial. So in the denominator, k is how many we choose, n minus k is how many we don't choose. And there is a symmetry involved here. For example, if I change k to n minus k, then these two factors in the denominators are switched, and we know multiplication is commutative, and that doesn't change the result. So there is a symmetry. So here's an example. Find the combination of 5 choose 3. That makes 5 factorial divided by 3 factorial times 5 minus 3 factorial, which is, let me rewrite it this way, 5 factorial divided by 3 factorial times 2 factorial. 5 minus 3 is 2. And what is a factorial? 5 factorial is 5 times 4 times 3 times 2 times 1. All the numbers from 1 up to that number 5, that is given 5, are multiplied. The same for 3 factorial is 3 times 2 times 1 times 2 factorial, which is 2 times 1. So now we can simplify. It's much easier not to multiply out the numerator and multiply out the denominator and get 2 big numbers and then divide big numbers. That's not a smart way to do this. The smart way is to divide first before you multiply. So notice that I have a 3 times 2 here, times 1. That 1 is not going to, you can ignore all the 1s. 3 times 2 times 1, that tail is eliminated with this tail, 3 times 2 times 1, right? You divide by 3, divide by 2, and ignore the 1. And then denominator now is 2 times 1, which is 2. That can simplify with the 4, and that gives you a 2 here. So the result is 5 times 2, which is 10. Now let's look at all the combinations of 5 objects, because you can choose 0 object, 5 choose 0. You can choose 1 object, you can choose 2 or 3 or 4 or 5. Let's see what these numbers are. So first, 5 choose 0 according to that formula. By the way, this is easy to know. The answer is 1. How many? You have 5 objects. How many ways can you not choose any of them? There's only one way, with an empty hand. So 5 choose 0 is, according to the formula, I'm going to just demonstrate the formula. We know the answer is 1. You don't need to use the formula. So it's 5 factorial divided by 0 factorial times 5 minus 0 factorial. One of the things about factorial, 0 factorial, by definition is 1, because 0 happen to be below 1, and the definition requires multiplying from 1 up to that given number. So in that sense, we define 0 factorial as 1. So 0 factorial is not 0. Okay, make sure you note that. Okay, now so what I have here is 5 factorial, whatever that is. Don't multiply it out. 5 minus 0 is just 5, so that too is 5 factorial. 5 factorial over 5 factorial. Any number over itself is 1. So 5 choose 0 is 1. And now let's do 5 choose 1. 5 choose 1. This too is easy to know. The answer is 5. Why? Because you have 5 objects and you're choosing one at a time. You can either choose the first object, the second, the third, and so on. So there are 5 ways. So the answer should equal 5. Now let's see what the formula tells us. 5 factorial over 1 factorial times 5 minus 1, which is 4 factorial, right? I'm just writing the results of subtraction. So then I have 5 factorial, which is 5 times 4 times 3 times 2 times 1. You don't need to list all these numbers, except especially when they are big numbers. It takes a while to write all the factors. Understand, first of all, 1 factorial is 1, right? So I'm going to ignore that. 1 times anything is anything. So 4 factorial is 4 times 3 times 2 times 1. You should know that when you divide 5 factorial by 4 factorial, the 4 factorial eliminates all of those factors, and the result is just 5. So you don't really need to list all those numbers. Now, if it was 5 factorial divided by 3 factorial, you should know that that is 5 times 4, because from 3 down, they all cancel if it was 3 factorial, which is the case in the next one. So then next we do 5 choose 2, and that is 5 factorial divided by 2 factorial times 3 factorial. So that's equal to 5 times 4 times 3 times 2 times 1. This is 2 times 1, and then that's 3 times 2 times 1, and then 3 factorial, and that 3 factorial cancel out. 5 times 4 over 2 times 1. 4 and 2 simplify, so that gives you 10. And similarly, you do the others, but use symmetry. The next one is 5 choose 3. So 5 choose 3 is 5 factorial over 3 factorial times 2 factorial. Notice that the 2 and the 3 are switched. The 2 factorial and 3 are switched. So this is the same as 5 choose 2. And that 2 we found is 10. You don't need to calculate this one because you already done the arithmetic for that and use symmetry. And then the next one, 5 choose 4, is 5 factorial over 4 factorial times 1 factorial. And that 2 is 5 choose 1. You know, 5 choose 4 and 5 choose 1 are equal because in the denominator, multiplication is commutative. You know, these two switch, like look at above. You have 5 factorial over 1 factorial times 4 factorial, and the result was 5. And then finally, 5 choose 5 is also 1, just like 5 choose 0. So in other words, you have 5 objects. Whether you choose all 5 of them together, that's one way, or you choose none of them, that is one way. So in both answers you get 1. So now let's relate this to the Pascal triangle. It's not an accident that in the 5th row you have 1, 5, 10, 10, 5, 1, and those are exactly these numbers, 1, 5, 10, 10, 5, 1. So in other words, this one here is 5 choose 0. This one is 5 choose 1. Here's 5 choose 2. Here's 5 choose 3, which ought to be the same because 2 and 3 added together you get 5. And this is 5 choose 4, which is the same as 5 choose 1 because when you add 1 to 5 you get 5. And this one is 5 choose 5, which is the same as 5 choose 0. So these are the binomial coefficients, we call them, and also they are combinatorics, combinations of from combinatorics, combinations of 5 choose 2. So we can see all these different fields, they're related. Combinatorics, that tells you the number of ways you can choose a certain number of objects from a group of objects, is related to the coefficients of binomial powers, which we saw in the previous video. These are the coefficients of x plus y raised to the 5th power. And now in the next video, we formally introduce the binomial theorem.